Okay, the angular speed of a wind turbine is pi over 60 radians per second. The length of each blade is 42 meters. Point A is at the edge of one of the blades, as you can see on the diagram there at the top. Calculate the distance traveled by point A 4 minutes from the instant shown. Okay, so firstly, we can figure out the speed using this formula here, omega times r. So I'm going to take pi over 60, which is my omega, my angular speed, and times it by 42. Okay, that gives me 2.2 meters per second. And I want to figure out the total distance traveled in 4 minutes. So I'm going to turn that into seconds. Using this equation here, the distance traveled equals velocity times time. Okay, and then that gives you 528 meters traveled in total over that 4 minutes. Okay, I could have also done this using a different method. So I could have figured out the angle it is turned through in 4 minutes. So if I use my omega, which is the angle it turns per second, times it by 4 times 60 seconds, that gives me the total angle, and then I can use the 4 pi, and then I can use arc length here, which is the radius times the angle turned in radians. Okay, that gives me the same distance. Okay, now part B is asking us to calculate the displacement, which is a vector of the point 4 minutes after the instant shown. Okay, so before we're calculating the distance, now we're trying to calculate how much is displaced from this point here. So again, I'm going to figure out the angle turned first, actually. So I'm going to do this equation here. So I'm going to do omega times t. So that gives me the omega, which is the radians is 10 per second, times 4 minutes times 60 seconds. So it's turned through a whole angle of 4 pi. Now 4 pi, that's 2 complete rotations. So it's going to go around once and then twice again. It's going to end up in the exact same place. So the displacement from where it started is actually 0. Okay, what about a different point? Let's say 30 seconds after the instant shown. Again, I'm going to use this equation. I'm going to take the omega and times it by 30 seconds this time. That gives me pi over 2. Now that's a quarter of a rotation. That's 90 degrees basically. So after a quarter, it's going to be right over here at this point there. Okay, so this you can see is actually like 42 meters from the center because the blade has a radius of 42. Okay, so I want to calculate the displacement from A. So I'm basically trying to figure out this distance traveled there. Okay, so I can use Pythagoras. So 42 squared plus 42 squared and square root, that gives me 59 meters from where it started. That is the displacement from where it started. I should also give an angle. So here it's gone 45 degrees because we know this is 90 degrees. Okay, so that's the angle displacement. So, and these two lengths are the same, so these two must be 45 and adding up to 180. Okay, this diagram shows two gears, A and B. Gear A here has 20 teeth and is spinning at a frequency of 120 Hz. Gear A is attached to gear B, which has 60 teeth of the same size. Calculate the frequency at which gear B is spinning. So firstly, let's draw a rough picture like this. You can see gear B here is at least 3 times bigger. Because it's got 3 times the number of teeth, it also means that it should have 3 times the circumference. So if it has 3 times the circumference to fit all those teeth here, it should also have 3 times the radius. Okay, so then we need to look at what's going on here. So when there are 2 points at which they're touching, where the gears are touching A and B, the particles need to be moving at the same linear speed. If they weren't moving at the same speed, so let's say for example one is moving at 2 meters per second and the other one was moving at 2.5 meters per second, then they would go into each other. So we want to avoid this, so those two have the same linear speed, so that doesn't break. Here's an equation for speed. Okay, and then in this one, because we don't have angular frequency, I've got normal frequency, I just can use this equation here. Well, they're directly proportional, and the 2 pi here is not going to make a difference because I'm going to use this as a proportionality question. So at the end, I get this equation here. So the speed is proportional to the frequency and the radius. Now we know that the radius for the second one, B, has times 3 the radius. Okay, so that must mean its frequency should be a third. It doesn't need to be spinning at a high enough as fast of a rate compared to A, which because it's got such a small circumference, it needs to be spinning at a higher rate. Though keep in mind at the point where they're touching, they're actually both moving at the same linear speed. So therefore, if we take the frequency of A here and divide it by a third, we get 40 Hz. That is the frequency at which gear B is spinning.